All right, we're going to go ahead and get started here. Good morning, everyone, and welcome to our webinar on Jumpstarting Your Health Data Strategy. My name is Casey Post. I'm the Senior Vice President of Sales and Client Services, and I have the privilege of kicking off our webinar today and introducing our speaker. Just a few housekeeping items before we get started. We are recording this webinar, and a link to the recording and slides will be provided afterwards. We will have a Q&A session at the end. So if you have questions as we're going, please drop the questions in the Q&A section here on Zoom, and we'll make sure to answer those at the end. And if you do want to ask your question live and in person, just raise your hand on the use the raise your hand icon, and we will unmute you during the Q&A session so you can ask your question live with Dr. Rahman. I am going to give you a little bit of background on 314E before we jump into this. But so 314E was founded in 2014, initially to provide resource staffing and services, implementation services. We're exclusively focused in the healthcare IT space, headquartered in the San Francisco Bay Area. We have a regional office on the East Coast in Philadelphia, and we have a development and delivery center in Bangalore where we're delivering services and developing products for our clients. We're have always been organically grown, no external funding, and we hold many industry affiliations and partnerships with professional organizations like Chime and HIMSS and HFMA, as well as a lot of EHR vendors like Epic, and we're working with Cerner and Meditech and others. We also work with a lot of the analytics platforms and cloud platforms like Microsoft, AWS, Snowflake, Tableau, and Qlik. And from a standpoint of class rankings, we're best in class for technical services and consistently ranked high for HIT staffing and implementation services. Next slide. And this is a summary of all the services that we provide. So we're, again, full suite of IT services for our healthcare or clients, everything from EHR to ERP implementation services on end-to-end to interoperability services. We're providing a lot of data analytics services, as well as technology services like programming and robotic process automation, as well as digital transformation and cloud adoption. And as we're going to talk about today, we're in the process of developing products and solutions for our customers in addition to providing services. And so with that, I will kick things off here. So the healthcare industry generates more data than we know what to do with. If you can leverage that data, you have better insights, enhanced decision-making, and a higher return on investment. We have organized this webinar to help you overcome critical challenges like high data latency, inability to scale, fragmented processes, and failure to deal with the varied data sources. Our speaker today, Dr. Shiv Rahman, the Chief Product Officer of 314E, is a physician and clinical informatics expert. He has over 18 years of healthcare industry experience and has held senior leadership roles in clinical informatics in various organizations, including Optum. At 314E, he is leading the development of our health data platform product. Dr. Shiv Rahman is also an author and has written several books on U.S. healthcare and analytics. The key takeaways from today's webinar will be around creating data platforms attuned to the needs of the future, strategies for managing various healthcare data types, reconciling data from multiple sources, and enabling advanced analytics and ML AI on the data platform. Over to you, Dr. Rahman.
Thank you for the introduction, Casey. So the webinar title is Jumpstart Your Health Data Strategy, but what I'm going to be doing is walking through some best practices that we recommend when you're developing and implementing a health data platform. Because things have changed drastically over the last 10 years in terms of how you go about doing that. And there are new insights that we want to share with those organizations that are in the process of implementing a health data platform, or revitalizing or redoing their platforms, because there are a lot of organizations that have already implemented platforms for analytics and data management 10 years back, and now they're seeing that their platforms are needing to be redone or juiced up. So when we talk about healthcare data, there's a whole lot of data that can be included under the domain of healthcare. But the most important types of data that a healthcare data platform will need to manage are the following. So there's clinical data from EMRs. There's medical and pharmacy claims. So whether you're a provider organization or a payer organization, nowadays with provider payer convergence and value-based reimbursement and so many other things happening, both types of organizations see both types of data. In addition, there's care management data from your care management systems, utilization review and disease management and case management. There's omics data, which is proteomics and genomics data. Only some organizations have that kind of data, but the volume of that type of data is expected to grow. And then there's social determinants of health and other related data about your patients or members from external sources. Now, there's also non-healthcare data that is linked to this healthcare data that might need to be managed on your health data platform. So that would be data from ERP systems or CRM systems. And so since it's about the same population of patients or members, you might want to link it on your platform to the healthcare data that you're managing. Now, when we talk about healthcare data platforms, I want to make it clear that I'm restricting myself to OLAP platforms, which means online analytic processing. So the other category of systems is OLTP systems, which is your online transaction processing systems. And that would be your core system that you do, that you use to manage operations, like your EMR system or your ERP system or CRM system. But usually when you want to do analytics and you want to understand your data and you want to do advanced algorithms for data science or other use cases, you don't want to do that directly on your OLTP system. You want to have a separate health data management or health data platform that is enabling advanced analytics. And so when you look at organizations in terms of where they are with their health data platforms, you usually find that they are in one of three stages, right? The first is where they have fragmented data in multiple databases and data stores, not really an enterprise analytics platform. And so the analytics that this sort of stage supports is rudimentary because a lot of it is done directly against the OLTP system or in small databases that are kind of extracts from your OLTP system. The second stage is, where you have an enterprise data warehouse and possibly an operational data store. So this warehouse is usually relational. It is loaded daily or weekly or monthly with data from the OLTP system. And the analytics are usually done from that data. And that warehouse might also have non-healthcare data coming in from other systems. And the linkage is done for that data to the healthcare data. The third stage, which is the most advanced as of now, is where you have some sort of big data architecture that supports both a data lake in addition to an enterprise data warehouse. So you have a situation where you're able to stream in the data on a real-time basis into your data lake, but then you're also able to move it through ETL processes to your warehouse. So you're able to do analytics on both your data lake, which is more real-time, but more unstructured data, and then the warehouse, which has your standard schemas, Snowflake schemas or star schemas, and cubes for doing analytics. And so that's the third and the most advanced stage of a health data platform. Now, there is a poll I would like you to answer, which will let us know what stage do you think your organization is when it comes to your health data platform? Gaurav, is that poll out? Okay. Great. So do please vote. And so we'll process those poll answers later. Okay. So what are the use cases for a robust health data platform? There are many use cases, and usually the very reason why you might be looking to implement or redo your health data platform is because your current setup may not support one or more of these use cases. They're clinical and financial reporting, business intelligence, competitive intelligence, visualization and dashboards, clinical measures, compliance, mandatory reporting, population health management related analytics, which is becoming an important area, AI and ML, and then lastly, applications and APIs built on top of the data platform. So I'm going to move on to the best practices we recommend, right? So best practice number one when you are implementing a health data platform is, at least for the clinical and the claims data, you should be using industry standard data models. So because otherwise you will have a situation where you're not able to reconcile different data coming in from multiple sources. You're having trouble making sense of what a particular field or a particular data item means. And for both clinical and claims data, we recommend the FHIR based models, right? So FHIR, or Fast Healthcare Interoperability Resources, this is an HL7 standard that came out a few years back. And for clinical data, it is now being widely accepted as the de facto standard. And so what you should be doing on your health data platform is making sure that your data is modeled according to the FHIR standard for clinical data. Now, that doesn't necessarily mean you store it in the hierarchical or JSON-based representation that FHIR recommends, because you can always convert it to some sort of relational model that is still based on FHIR that supports analytics in a more easy fashion. But your baseline, your base standard should be the FHIR standards for various EMR data resources. For medical and pharmacy claims data, again, you have some options. You can use the explanation of benefits resource in FHIR to model that data, or there are these all-payer claims databases that almost every US state has set up to receive data from multiple payers, and they publish their specifications on their websites. And so most of these specifications are pretty similar. There's also an APCD common data layout that can be used that kind of reconciles all the different state level specifications. So whether you go in for FHIR or for APCD based data models for your medical and pharmacy claims, we recommend going in for the FHIR one and then extending it with the with any attributes that you see are extra or are found in the APCD specifications but are not covered in FHIR. Those would be very few, but they might exist in some cases. So the second best practice is to implement an enterprise master patient index or master entity index upfront. So what's an EMPI as it's called? When you're getting data from multiple sources, there's no universal ID in place in universal patient ID or member ID in place in the US. So when you're getting data from multiple sources about the same set of patients, you could run into trouble if you're not able to link different types of data or different streams of data about the same patient or same member, because you don't know whether this is the same individual or a different person, right? So, and you can't really use social security number or something like that as a proxy, because in many cases, especially when you have a subscriber versus member relationship, all of the members, dependent members under a subscriber might be assigned the same SSN. So there's various situations where what you need to do is implement an EMPI. And what that does is an EMPI uses probabilistic as well as deterministic algorithms to figure out whether patient A in stream X is the same as patient B in stream Y, right? So if the algorithm says that these are the same patient, then you can combine the two types of data under the same patient ID. If not, you keep them as separate patients or separate persons. Now, there are several commercial as well as open source offerings for EMPI. Open EMPI is an open source EMPI that you can look at. Commercial offerings include, Argo Data and IBM's Initiate and multiple other companies that provide an EMPI. So, but that's the second best practice that we would say you absolutely need to adopt, which is to implement an EMPI early on in your health data platform setup. The third is to manage your ETL and ELT effectively. So what's ETL? So ETL is the process of extracting data from the source systems and loading it into a warehouse. So E stands for extract, T stands for transform, and L stands for load. Now, traditionally, that was the sequence in which this stuff was done, or these processes were undertaken, because you would first extract the data from your OLTP system, transform it into the schema that you want it to be when it exists in the warehouse. And then lastly, you would load it into your enterprise data warehouse in some sort of star schema or snowflake schema. And that would then support analytics. With the advent of data lakes, the ETL changed to ELT. So what that meant is that you still extract the data from your source systems, but then you just load it into the data lake first as is. You don't really do much of transformation. You pretty much land the data in your data lake so that it can be used directly for analytics. It's a little bit difficult, but for those who understand the data structure and with modern tools, you're able to directly do analytics on the warehouse, on the data lake. And then you transform it for the various use cases, one of which would be loading into an enterprise warehouse. So ETL kind of changed to ELT because of the advent of data lakes. Now, there are architectures like the Lambda architecture that are used in order to set up an effective ELT or ETL process. So what the Lambda architecture does is it has batch, speed, and serving layer. So the batch is for the slow moving and the high latency data that you load and you kind of make it available within the warehouse. The speed is for the streaming data that comes in near real time. And then both these types of data are served up from the serving layer. And then you use various processing tools like Spark, Kafka to set up your ETL infrastructure and processes. Now, this is where we have a recommendation, unless you are already down the route of setting up the whole data lake and you've already got an existing data lake and data warehouse set up. We would say, please do consider a lake house architecture instead of a traditional data lake plus data warehouse. And that's because, so what's a lake house? It's an architecture that came out just about a year or so back. It combines the best of what a data lake offers with what a traditional enterprise warehouse offers. So you have low latency and support for analytics, just like a data lake. At the same time, you have the relational support, and the traditional warehouse architecture also can be implemented within a lakehouse. And there are various implementations of this lakehouse. One is the Databricks Delta Lake platform. There's another one called Apache Hudi. There's Apache Iceberg, which are both open source. But what a lakehouse offers you is the ability to do what you were able to do with a data lake and a relational warehouse, but having avoiding the problems with data lakes. For example, no support for ACID transactions. So I'll talk about this a little bit more, because we also at 314E have a health data platform that is based on the Databricks Lakehouse, and it's optimized for healthcare. There's the next best practice is to enable the use of multiple tools, right? So when you have the data platform set up, you're trying to address the use cases that I talked about earlier. But at the same time, you want to enable the use of multiple tools as well, because there are so many tools that are now used to do analytics and other operations within a data platform. So number one would be standard BI tools, Tableau, Cognos, etc. Reporting and analytics using programming languages like Python, R, SAS, SPSS. Visualization using libraries as well as languages. And lastly, you want the platform to be able to support AI and ML algorithms, predictive models, using Python, Spark, Scala, R, Java, multiple languages. And so if you have a traditional data warehouse, that might support one or two of these use cases, but it will probably not support AI and ML algorithms being run directly in the warehouse. So that's why a modern architecture like a lake house or a data lake plus warehouse will support all these use cases. And that will allow you to get maximum value out of your platform. And then the last, but certainly not the least, best practice is to enable additional processes, right? So, for example, when you've got clinical claims and other types of data coming in on the same patient, you want to make sure that this is above and beyond the EMPI, right? So the EMPI will link different types of data on the same patient. But even there, you might have two different streams of data that say different things about what the set of clinical services for that patient were. So you have to have a process for kind of figuring out what the source of truth or the correct record is. You need deduplication algorithms. If you get the same set of claims repeatedly on the patient or member, you don't want a situation where you're showing 16 encounters instead of the 8 because you've got two different streams coming in. You need to absolutely implement master data management, which includes an understanding of the source of truth and also a single version of the truth when it comes to facts about the patients and members. And lastly, you need some sort of quality control as you're going through your ETL to ensure that bad data doesn't make it into your platform, and that can lead to multiple problems, especially with the veracity of your analytics. Okay, so I'm going to go on to discussing some of the problems that current warehouses and data lake type setups have in terms of, and why we are recommending for those organizations that have not already implemented a data warehouse and data lake setup, that they should go in for a lake house type architecture. Firstly, you have the problem of data staleness, right? So if you have only the warehouse, you have staleness, data latency, which is high. If you're loading the warehouse only weekly, then all of your data there is at least a week old. So the second is reliability. Thirdly, you have a problem, even if you have a full warehouse plus a data lake to support the near real-time data transactions. The total cost of ownership can be high because you're setting up all of these complicated Lambda architectures, etc., that require a lot of complexity and a lot of resources to maintain. Now, you also have limited support for advanced analytics in your warehouse, for sure. Even in a data lake, a traditional data lake, because of the next point, which is data lakes as they are architected today do not really guarantee atomicity, consistency, isolation, and durability. So any data there, if you're reporting on it or you're doing analytics on it, may or may not be completely correct. So these are all the reasons why we are, we have a 314E has a Muspell health data platform that we license to those healthcare entities that are interested. We also provide health data services. So if you are very happy with your platform as is, but you want some stuff done, we also provide services in that realm. So you don't really have to license our Muspell platform as a product, but you can also use our health data services for implementing new things on your existing platform. but the Muspell platform itself offers things like SQL compliance, asset transaction support, full support for ML and AI. We, as I talked about, the industry standard data model. So whenever we set up ETLs on the Muspell data platform, we make sure that the data is based on FHIR and standard data models. We incorporate master data management, quality control, and easy access through multiple tools. And lastly, we support applications and APIs. So if you want to know more about the Muspell Health Data Management and Analytics Platform, please reach out to us. If you're interested in services related to data or your data platform as it exists in your organization today, please reach out to us for that as well. So that's the end of my presentation, and I will take questions now.
Well, thank you very much, Dr. Rahman. That was great, great presentation. The results of that poll were, not surprising. About 2/3 had fragmented data in multiple databases, and another third had enterprise data warehouses, with nobody reporting that they had a data lake plus data warehouse. So I think that the question came in about what are the steps an organization needs to take to develop a health data platform are relevant given those results.
Right. Yeah, and that's the reason why I was kind of holding off on the second poll, which was, do you have a data science team? So maybe we should do that poll as well now. And in the meantime, I will also take questions.
And a reminder, if anyone has a question they'd like to ask live, just raise your hand and we'll unmute you to let you discuss.
Okay, so I'm seeing one question come in here. So what are the steps an organization needs to take to develop a health data platform? Okay, so I think the first thing to do when you're evaluating your strategy for developing health data platform is to identify your use cases, right? So I had covered those use cases earlier because many organizations don't have all of these use cases. But the reason why your health data platform as it exists today will start showing its age is because one of these use cases is difficult to address on it. So the first step is to identify the use case or the list of use cases that you're going to support on your health data platform. And then at that point, you want to start looking at the technical implementations or the technical architectures or the products that support those use cases. So don't go in technology first when you're developing a health data platform. Instead, try to understand what are all the things that you want to do on your health data platform. And then once you've identified the use cases, then you look for technology solutions to address those use cases. I'm seeing another question here. Let me just check. Should we go in for a cloud-based platform or an on-premise one? So I think more and more organizations are going in for cloud-based platforms, especially when you're doing a data lake plus a relational data warehouse. The world seems to be moving to the cloud. That doesn't mean that you cannot implement a platform like that on premise, but it just means you will then have to manage your hardware and your servers and your Spark clusters on your own. And most organizations feel that it's easier to put that out on the AWS or Azure or Google Cloud and have that platform be managed on the cloud rather than doing it on premise. Okay. There's one question here. It says, what will be the scope of healthcare data analytics? Well, the scope of healthcare data analytics is very broad. If you want to categorize it, I think there are 3 categories of analytics. The first is what is known as descriptive analytics, right? So you have, you want to just know what's happening, like you want to slice, dice, you want to show financials, you want to show encounters, clinical measures. These are all descriptive analytics. They usually don't require more than your standard BI tools or SQL in order to deliver them. The second category is called what is known as predictive analytics, right? So you're kind of not only interested in seeing what's happening, but also interested in understanding what is going to happen. So that usually involves some sort of AI, ML algorithms on top of your data, in addition to just the descriptive analytics. And the last is called prescriptive analytics. So, you're able to predict, but you also want to recommend some action, whether that's some clinical decision support action or some sort of financial action. So that's called prescriptive analytics. So a robust health data platform should be able to support all 3 types of healthcare data analytics.
I think we have one last question here, Shiv, is what are the kinds of resources required to manage a modern health data platform?
That's a very good question. So an old school ETL with just a warehouse used to be simpler to manage, right? You would have data architects and data analysts who would be pretty much able to do all of that. When you move to something more modern, like a lake house or a data lake plus warehouse architecture, there are various types of resources that might be required. So you have data engineers who are in charge of managing the ETL, the ELT, getting the data in, moving it into the warehouse, moving it into the data lake and making it available, transforming it, of course. You've got cloud architects. If you're implementing this platform on the cloud, you obviously have your traditional data analysts and BI folk, and you also have data scientists, because if you're trying to get predictive models and other value out of your platform, you need a data science team. And so one really good book I read on the topic about building analytics teams, which includes data teams, is it's called Building Analytics Teams by John Thompson, I think. And that's a good book, because if you're setting up a platform, you also need to know whom to hire to manage it. So I think you don't have to always hire. In some cases, you can train existing resources, but a robust modern healthcare data platform requires a different set of resources and skill sets than a traditional one.
Wonderful. Well, I think that's it for our questions. I want to thank you for your time, Dr. Rahman, and for this presentation. And I want to thank all of our guests for joining us on this webinar. Again, we'll send out the slides and the recording of the presentation shortly after this. So if you have any questions or you care to discuss any of your healthcare data analytics, initiatives with 314E, we'd be glad to have a conversation with you. Thanks again, and have a great day.